Hey guys, welcome back. Today should be Monday, the 24th of March. Today we're going to move on from surface area and we're going to talk about volume. So today and tomorrow we're going to talk about volume. And then on Wednesday, we're going to bring surface area and volume together. You guys are going to be doing practice with one figure finding the surface area and the volume of each. So just like surface area, we're going to split it up between 2 days. Prisms one day and then pyramids and cones another day, just because the equations are a little bit different. I taught you surface area first, and I actually think surface area is a little more difficult than volume. Volume is just generally the base shape. So if I have a cylinder here, a base shape is the circle. And if I take that circle, the area of that circle, and I just stack up all these like circles until it's full, I just take the area of the base and multiply it by the height, and that gives me the volume, because volume is just the amount of space inside this cylinder, how much it can hold. So let's look at that. So first we're going to start with prisms, and let me share my screen while you get your notes out. So we're on this first page, or this is page number 5 in your notes if you're not there yet. We're going to start with just a rectangular prism or a cube. They're both the same. The volume, you should know this from science class, is just length times width times height, and you just multiply all 3 values together. It should be very, very simple. These are always my favorite because I think they're so easy. But length, width, and height does not necessarily matter which order on a rectangular prism or a cube. It's all the same. So L is 9 times 17 times 24. That's why order doesn't matter. It's because you're just multiplying them together, and you can multiply things in any order and you still get the same value. 9 times 17 times 24. The volume of this rectangular prism is 3,672 centimeters cubed. That's the one thing that's new. That centimeters cubed. Volume is 3D. Three-dimensional, that's why it's cubed. We put that 3 there. That's really annoying. Why does this think it's a face? The next problems are really the same. I think you could try them yourself. We have our length, width, and height. You can label those as any shape. Any sides can be your L, W, or H. The other shapes, when we change the base to either triangle, or a trapezoid, is when things get a little different, just because, again, you have those 2 different H's, and an H for the actual shape that the base is created after, and the H of the height of your actual 3D figure. So when I approach a problem like this, my favorite thing to do is to highlight or outline the base, because that helps my brain organize everything. So I see that there's a triangular base in this problem. There's not, all sides are not rectangles. That's how I know it's a triangular prism. And so one of the bases, you can either highlight the front or the back, whatever your heart desire. This is my triangle that I'm working with. Area of a triangle, I put area of a triangle, that's how I like to write that, is 1/2 base times height. That is right off the blue formula sheet. 1/2 base times height. In that triangle, that 7.3 is the height. It's that dashed line perpendicular to the base. Wherever it's perpendicular, that 12 is the base. So I have 1/2 times 12 times 7.3. That gives me the area of the base. Because my volume, like I said earlier, is just area of the base times height. That's really what we did before up here at the top. Length times width is area of a rectangle times the height of the actual 3D shape. So it's area of the base times your height. down here. Your base, we're just putting big B as area of the base because your base is going to change shapes. It could be a triangle, it could be trapezoid, it could be really any shape we want it to be. In a cylinder, it's a circle. So your area of the base, going back to this problem, is 43.8. That equals my big B. And then H. Yes, we already talked about H. H in the triangle is 7.3. But H over here is H, the actual distance between the two triangular bases. It's the height of the 3D figure. So that base, the distance between my two triangles, can you figure out which distance that is? Is it the 12, 10, 7.3, 9, or 5? In this problem, the height between those two triangular bases is 5. So I'm going to label that as my H for my, oh, we can't even see them. The height of my 3D figure is 5. So all I do for volume is multiply my big B, which is 43.8 times 5. That gives us the volume of 219 feet cubed. Let's try another triangular prism together, just to make sure we've got it down. Number 5, I have my triangular base. I'm gonna just outline it because that helps my brain. You might be better than me and be able to see it, but color coding or coloring, shading, however labeling works for you, it's probably gonna help you stay organized. So my base is that triangle. The base of that triangle is 11. The height of that triangle is the dashed perpendicular line is 5.4. So my area of the triangle, or my big B, is 1/2 times base times height. Again, this 1/2 BH is right off the blue formula sheet. You should have that out. That gives us a 29.7 millimeters squared area of the base. And then the height of my 3D shape is the distance between the two triangle bases. So the front's a triangle, the back's a triangle. The distance between them two is 16 total. I just thought the mm was a point something. I jumped ahead. So I'm going to use my area of the base and my height. My volume is 29.7 times 16. Gives me a total volume of 475.2 millimeters cubed. Oh, I sort of ran out of room there. We can also change up that shape. We can make it anything else. So let's try number 6, because number 6 is a trapezoid. Again, in my trapezoid, I'm going to outline my base because it just helps my brain. There's a lot of numbers, a lot of like extra lines going on in these pictures. It gets very confusing. Outline that base. I see 14 is base, 36 is a base, and 17.9 is my height. Big B, or area of that little trapezoid. The formula of your formula sheet is 1/2 your height times B1 plus B2. Remember, because that trapezoid has two bases, the bottom base and the top base. It doesn't matter which one you make B1 and B2. I usually just make B1 the smaller one. B2 is going to be this wider side. So that's 36. So that's my B2. I can also write 36 here if it helps you out a little bit. And then the height of that trapezoid, again, has to be perpendicular. Height has to be perpendicular. So it's my little h. I'm using blue for my bases. So I'm going to plug that in. I have 1/2 times 17.9 times my two bases added together, 14 plus 36. That's nice math, that's 50. So 50 times 17.9 times 1/2, or 1/2 of 50 is 25. 25 times 17.9. The area of my base is 447.5. That area of the base is almost as much as the volume of the last problem. And then for the other H that I need for volume, because volume again is just area of the base times height of the whole thing. The height is the distance between those two trapezoids. So the distance between those two trapezoids is 25. So I have 447.5 times 25, the height. That gives me 11,187.5 meters cubed. I think these are a little more simple than surface area were, but I still want to look at one more shape today. And I want to look at a cylinder. Cylinder, the formula is still area of the base times height, even though it's written as pi r squared, because pi r squared is the area of the base. Almost looks like a heart. Area of the base is pi r squared, so area of the base times your height. For area of the base, you need your radius. And then the 15 is the height of the actual figure. So if I plug those in, volume equals pi r, which is 18, squared, times h, which is 15. Plug that into your calculator or Desmos, or just do it in your head, however you feel is necessary. Our total volume is about 15,268.14 inches cubed. Cylinders are probably gonna be your favorite because I feel like, oh no, rectangular prisms are pretty easy, but cylinders are like very easy. So I think in cylinders sometimes are going to be given a diameter rather than a radius. And so you would have to find your radius by cutting that in half. 11 divided by 2, 5.5. So you can try number 10. It's not necessarily something I want to do with you. I would like to take a moment though and try a problem like number 11. Number 11 is using this shape off to the left. Sorry, I had to really think about what direction that was in. Because we have two shapes and we're cutting a shape out. So we're combining a triangular prism and a cylinder and subtracting the two. We're cutting a hole out of that triangular prism. So to start off with the triangular prism, I need the volume is area of the base times height. Area of the base is that triangle. 5 and 5. 5 is the height. 5, the other 5 is the base, because those, if you see that little tiny right corner, that's your perpendicular height and base. So the volume would be 1/2 times your base times your height. Oh, sorry, that's supposed to be big B, not V. And then we can multiply by the height of the entire thing. I'm gonna label that. Let's do blue. Nice UVA colors, or Denver Broncos. The overall height of that is 14. So I'm gonna put a little like triangle. This is the triangle volume. The volume, area of the base times height, if you calculate that, the volume of the triangular prism is 175 centimeters cubed. And then I can also find the cylinder volume. The cylinder volume, the area of that circle, I need to pay attention to this. My 2 centimeter diameter means the radius is 1. So I have pi times 1 squared times the height of my cylinder is the same as that. Triangular prism of 14. So pi times 1 squared, which is 1, so pi times 14 is about 43.98 centimeters cubed. And this is where you have to decide. Some problems you will have two things like combined and you add them together, or you're going to have a hole cut out of something, and that's where we're going to subtract. So we're going to take 175, subtract our volume of that cylinder that's being cut out to give us our total. So I'm going to do that over here. Let me get a different color. 175 minus 43.98 gives us a total volume of 131.02 centimeters cubed. So we are going to stop there in our notes. You are going to work through your homework number 3. Let me get that out really quick. I was not prepared this time. So I can tell you which problems you're doing. So give me 1 second. On homework number 3, I would like you to complete problems number 1. I'm getting a pen to write this down. For this, number 1, number 2, number 3, number 4, number 9, let's try number 12, and number 14. So again, on your homework today, you are completing, problems 1, 2, 3, 4, 9, 12, and 14. So 7 total problems. That is all for today. I will see you back tomorrow.